Hi everyone, my name is Juan Carlos Camacho and I'm going to explain the topic of two-dimensional motion with constant acceleration. First of all, you have to know something. The projectile motion. A projectile motion is when you throw something or something is thrown like this, close to the earth, and it has a maximum height and it goes like this, like in a parabola, like this. Well, once we know this, you have one specific thing you have to know now. It's that when the object is thrown, the particle is thrown, we have initial velocity. Initial velocity is the force that the object has when it's going down, it's going up. So it has a relationship with the vector quantity. Remember, the vector, like a vector. You understand? Easy, right? Well, this motion has its components in y and in x because it's like a vector. It's thrown, has its component in x, component in y. How can you calculate? Easy. For this, you only have to use these formulas I already explained in topic 3. This is initial velocity in x equals to initial velocity times cosine of the angle, and in y it's almost the same but with sine. Initial velocity in y equals to initial velocity times sine of the angle. Now guys, you can think, what is this for? What are we doing all this? The components. Well, it's very simple. With these two, the initial velocity in x, initial velocity in y, we can solve for another concept that are maximum height that I have already explained. That is when the object reaches its maximum height, like the parabola is here, like this, maximum height, and then it falls, and the time it takes to do that. Well, with this information we can know the time already. You have to know first that when the object reaches its maximum height, the velocity finally is 0 because it stops to move and then it will fall again. So we can know the time already. And how we solve for time? Easy, because with this formula, the component in y that is here is 56.56 plus the multiplication of 9.1, that is the gravity, times time. But then we have all of these except time, so we solve for time, and it goes like this: 56.56 over 9.81 equals to time. The 0 here is because the final velocity is 0, and we already say that. And the result of the time is 5.7 seconds. And guys, please remember this time is just to the maximum point, maximum height. The time it reaches in the complete parabolic motion is gonna be times 2. That means that is 10 seconds and 0.14. Now guys, we have another very important part of this topic. That is the uniform circular motion. What is it? It's the rotational motion when it goes like this. Remember one thing, a circle has 360 degrees, and one round it's equals to one revolution. Another very important concept, revolution. And guys, remember, in physics we use a unit called radians. Very important. It's just the relationship between the arc and the radius. Well, the angle of the radian is the central angle in which the arc is equal to the radius. So it is defined by these following equations like this: one revolution equals to 2p radian. And we have another concept, that is the angular velocity, that is the angular displacement for some unit of time. And this creates another concept, that is revolution per minute, that is the frequency. And the last concept is tangential velocity. That is calculated by the multiplication of the angular velocity times the radius. And it's all for the topic, guys. Thanks for watching, and give like if you like it. Thanks, and see you soon, guys.